So we've been talking about evaporation and the temperature at which boiling happens. What happens if we vaporize a liquid in a sealed container with heating? So we've got a sealed container and we're going to heat the liquid. It's going to vaporize, but the pressure is going to build up. What's going to happen? Well, as that pressure builds up, the gas becomes more dense. As the temperature rises, the liquid becomes less dense. And it will get to a point called the supercritical point, or the critical point, where the gas and the liquid merge and they become one state. And that's known as a supercritical fluid. Generally only happens at high temperature and high pressure. These pictures here are a viewing window in a chamber. Here we see the liquid and the gas, and as the temperature rises, the pressure increases. From here to here, we see the line between the gas and the liquid disappear. Supercritical fluids are very useful as solvents. Supercritical CO2 is what they use to decaffeinate coffee, because the caffeine is soluble in the supercritical CO2, but the other compounds that are responsible for the flavor of coffee aren't. And so you can wash away the caffeine, and then when you're done, you just release the pressure, and any remaining CO2 just evaporates and is gone, and so it doesn't leave any residues behind. TC is the critical temperature. Above that critical temperature, you cannot have the liquid exist under any set of circumstances. The pressure that occurs at that temperature is called the supercritical pressure. I don't know, do you have any questions?
What happens to it if it goes above that?
Well, it's not a liquid and it's not a gas. It's a supercritical fluid, and so it's just sort of a merger of the two states. It's weird. It's very weird. Yeah. Like the title says here, an unusual state of matter.